Yeah, thank you. I have a script because it's quite some material I'm going to be reviewing here. So please bear with me, and for any missing details, I refer you not only to the paper in the publications, but also to the various publications referenced in the paper. So the story goes back to 1997. Let's take a moment, that's 20 years ago. This is when Jos van Och first developed, tested and employed a tissue gel composite approach for treating the paintings in the Oranje-Zaal in The Hague. Varnish removal from these 17th century oil-on-canvas paintings posed many complicating issues. The team comprised many conservators with different backgrounds, training and approach. Being an entire ensemble, the Oranje-Zaal treatment required a unified result. The total surface area of the paintings covered approximately 304 square metres, and there was a strict deadline for completion of the project. So what were the specific conservation demands? Well, the paintings were unlined and extremely porous, and swabbed free solvent to the varnished paint film was immediately observable on the reverse of the canvas. A method was required that would regulate the specific solvent mixture used and the contact time in order to diminish the effect of different hands and ensure an even cleaning. The varnish removal should be safely efficient and prevent penetration of resin residues through the painting structure. Thickening the solvent, as of the little video there. Thickening the solvent was a logical first step, and in this case, a cellulose ether was selected. This was because of its solubility in the chosen solvent mixture, because it's stable and maintains that behaviour, and because it's chemically inert. These were and remain particularly critical considerations for older paint films, since their typical cracks, losses and porosity increases the relevance of non-volatile residue concerns. For regulating the quantity of gel applied within a controlled working time, a gel-impregnated tissue was conceived, and this can be seen in the first picture. The use of a secondary dry tissue adjacent to it was found to maximise effective absorption and removal of the dissolved residues. After the specified time then, the dissolved materials could be pressed into the tissues above, which is in the picture below, and the package removed. With this approach, a very revealing intermediate cleaning step was provided, which was also useful for research purposes. And a unified cleaning was safely achieved with an apparently minimised exposure of the paintings to solvent. To this day, the annual controls carried out, here by the conservator in the photo, gives you a sense of the scale, have not indicated any negative side effects on the surfaces of these paintings. And neither solvent nor dissolved varnish residues were visible on the reverse of the paintings during treatment. Hence, degradation of the canvas resulting from acidic resin impregnation was prevented, a factor considered especially pertinent in this case and for unlined paintings in general. With reducing resin penetration as one of the general ideals, the intervening years have seen various developments and applications of a tissue gel approach at SRAL. I'll illustrate the adaptability of the approach and other general advantages through some selected case studies. The first example is these cupped and unlined paintings from Castle Amerongen. During testing, some typical problems using swabs and free solvents on such topographies was observed. Mechanical damage could be incurred on a macro scale with sharp, raised paint edges easily vulnerable to breaking. Swabs removed varnish from the peaks of the paint film while leaving residues in the cups. The varnish was not effectively removed from the cracks nor from under raised paint edges, which compromised subsequent consolidation. With a tissue gel application, macro-mechanical action on the vulnerable and cupped paint films was reduced, and to the extent that no paint losses was incurred. There was no direct rubbing on the paint surface or catching of cotton fibres as occurred with the swab. Also, less pressure was applied since the surface area of the tops in the cupped paint films was effectively increased by the tissue layers, and the contact layer was greater than that of a typical swab, and we've just seen in Barbara's talk other possible advantages. More effective removal of varnish from the cups could also be achieved, resulting in a more even removal from the entire paint surface. This even removal has been seen repeatedly on various varnished paint surfaces, and shown here are some comparative test areas before and after swab solvent and tissue gel cleaning tests. With the tissue gel cleaning, the gradational swelling of the varnish residues in typical paint cracks and under-raised paint edges from the top down, in other words, explains the frequent observation that application of free solvent to a recently tissue gel cleaned location no longer results in the penetration of the solvent through to the reverse. A positive practical aspect is that during the absorbent step, there exists a potential to remove more of these varnish residues, which in the case of these specific paintings meant that more resin material could be removed from the cracks, cupping could be reduced, and more effective consolidation could be subsequently carried out. But a theoretically negative aspect could be relatively longer solvent retention within these varnish residues. And a generally recurring theoretical concern had been the potential for an increased concentration of solvent being held at the surface. We could investigate this to a degree through collaborative research back in 2011 involving single-sided or unilateral proton NMR. Experiments with a simple paint model were carried out to examine the applications of a solvent in both free-form and as a thickened gel with tissues. We used a model because we found that the variation in layer thicknesses in real painting rendered accurate depth profiling difficult. We deliberately selected a solvent that provided a slow but ultimately high swelling for this model paint film and which gave a recognisable NMR signal. So not a realistic varnish removal setup, but one that enabled us to measure solvent penetration and potential effects in a comparative way. What we found was that the maximum level, the depth of solvent penetration, was found to remain comparable between the two techniques. In other words, the solvent reaches the same depth no matter the technique. But with the tissue gel composite, the quantity of solvent was significantly reduced, both at the surface and throughout the entire sample depth. So yes, few indeed. This solvent efficiency lies in the effective vertical action of the technique, which is best illustrated in the treatment example of these two portraits of Landgraf Karl van Hessen-Kassel and his wife. These paintings had been previously lined using an unusual oil-based and intensely red adhesive, which had gradually flowed from the reverse of the canvas through the cracks in the ground and paint layers and onto the varnish surface. It was very visually disturbing, and in terms of their solubility behaviour, the possibility of removing this lining adhesive simultaneously with the varnish layers was confirmed during solvent tests. But applications with swabs and free solvent were rather dissatisfactory. They resulted in smearing of the lining adhesive across the surface of the painting. With the tissue gel composite technique, varnish, old over paints and the lining adhesive residues were effectively removed without visible solvent penetration and, critically, in a vertical manner whereby redeposition was prevented. In another series of 5 very large canvas paintings from Kasteel Bruckhausen in Leersum, some of the painting's edges were so damaged and the instability of surrounding paint areas so extreme that any contact at all with the surface readily generated loss. In this case, a way was found to consolidate these areas temporarily and enable a safe varnish removal by first applying a facing of water-based tissue gel composites. After complete drying, thickened organic solvent was then brushed onto the adhered tissues to remove the varnish without original paint loss. There are many other projects where adaptations of the technique have been applied, but that's the end of my examples here. Since publishing this work, I've noted, of course, with interest surrounding discussions and all the developments. There are aspects about this technique I would like to accentuate its general disadvantages, specifically the reduced visibility of the film surface during treatment, the delayed ability, as exacerbated with various gelled solvent applications, to stop during treatment. Comprehensive pre-testing for solvent sensitivity is required, and then naturally any indicated solvent sensitivity of an original area should negate its use. But perhaps I should include naming it a technique, since no generalised solution can exist for a complex procedure like cleaning, and the way of it must be carefully related to the why of it. Conservators must critically rely on their experiences and observations of the individual painting at every point, and I want to accentuate that it was based upon that fundamental approach that tissue gel cleaning came into being and has been variously employed at SRAL. On that note, I would like to thank all my colleagues, my co-authors of the publications reviewed here, all the conservators who've ever experimented with this technique at SRAL, and to thank you for listening.